This is your lesson on section 8.1, geometric mean. Definition of geometric mean is that you take the square root and multiply two numbers together. If you're doing three numbers, you would take the cube root and multiply those three numbers together. Four numbers, you'd multiply the four numbers and you would take the fourth root. And we're probably not going to go any higher than these two right here. When we get to the three numbers, if you do not know how to use cube root on your calculator, you need to make sure you ask Mrs. Nick. Okay, so let's show you how this works. If I ask you to find the geometric mean between the numbers 10 and 20, you have two numbers, so you're going to use square root. So you're going to multiply the two numbers together and then take the square root of that. If I ask you to determine the geometric mean of 15 and 17, again you have two numbers, so you would take the square root of 15 times 17. When you're dealing with three numbers, however many numbers there is, that's the root that you're going to take. So to find the geometric mean of 7, 13, and 22, you are going to take the cube root of 7 times 13 times 22. Now, tomorrow I'll go over a little calculator lesson how to do this if you do not know how to figure this out. For you graphing calculator people, it's going to be under the math key. For scientific calculator, you're probably going to use the shift and the exponent key, which looks something like this. Each calculator is different. Okay, geometric mean in right triangles. If you have an original right triangle, like triangle ABC, it divides the triangles into two triangles if you have an altitude that leaves the right angle. So this altitude right here, if I drop it from the original right angle to be perpendicular to the opposite side, you're actually creating three similar triangles. Okay? You have your original one, which is the whole right triangle. Then you have this small one, which is ABD, and then you have this small one, which is BDC. So all three of these are going to be similar triangles. So each pair of triangles is similar. Determine X. Well, we just did a whole chapter on similar triangles. So if I were to take and redraw these so they're together, they look like they're, sitting side by side, you would set up proportion. Okay, so 40 over x equals x over 20. Now watch what happens, because I'm trying to prove to you how the geometric mean works. That means that x squared equals 800. So to solve that, you're going to take the square root of both sides. So you take the square root of 800, and x is approximately 28.3. Okay, so what we're saying says geometric mean in right triangles. If I wanted to find the measure of the altitude, which is BD, that would be the geometric mean of AD and DC, because that's what we just did on the last one. If you think about it and go back up, okay, X is the geometric mean of 40 times 20. Okay, and those were the two parts it was breaking up. So it would be the geometric mean of this part, AD, times DC. So, to find the value of x without having to set up a proportion, okay, using the same numbers, instead of setting up a proportion, 40 over x and x over 20, the shortcut is x is the square root of 40 times 20. It's going to be the square root of the two little pieces that altitude is chopping up. Okay, now this switches up a little bit when we're looking for one of the legs of the original right triangle. Again, if I were going to set up a proportion, and I didn't redraw my triangles, but if you wanted to redraw them so they're sitting the same way, to set up your corresponding sides, you would be going x over 30 and 24 over x. Where I got the 30 from is I'm using the big right triangle, Okay, so 24 plus 6 makes this entire side 30. So I'm using this right triangle and the original big right triangle. Okay, so that would be x squared is equal to 30 times 24. And you can finish that on your calculator. Okay, that means x is going to be the square root of 30 times 24. Okay, go ahead and finish that. Okay, so if I were to do it looking at the other leg, you're basically going to set it up the same way. Okay, if you were to pull your triangles apart and redraw them, you set up a proportion, you would do x over 20. Okay, that's this whole side right here. I'm looking at the big right triangle. And then 5 over x. Okay. Now this is kind of summing up what we're just doing, but I'm going to put it all together. So if you're confused, just hang in there for another minute or so. The altitude to the hypotenuse of a right triangle separates the hypotenuse so that the length of each leg of the triangle is the geometric mean of the length of the hypotenuse and the length of the hypotenuse segment adjacent to the leg. I know that sounds really confusing, but I'm going to put it in like a formula for you. And I strongly suggest you write down that slide. Okay, so what this means is when you're looking for one of the legs, you're going to take the geometric mean of its little part. Okay, so if we're looking for AB, you're going to take the geometric mean of AD times AC. Now it doesn't matter what order it's in. So you're looking for its little adjacent leg, that's what it meant by adjacent, and then its original hypotenuse. So if I'm looking for the other side, the other leg, BC, okay, I'm going to do the same exact thing. So the BC, you're going to do the whole hypotenuse times its little adjacent leg. Okay, so we're going to go ahead and do an example, and then I'm going to kind of wrap this up in a minute. All right, so my example, if I wanted to find AB, it's going to be the geometric mean of 30 times 25. Where I got 30 from was this whole side right here. Okay, that whole thing is 30. So you're doing its little adjacent leg times the whole thing. So to find the other one, okay, so that's AB. To find the other leg, you're going to do the same thing, just on the other side. So BC is going to be the geometric mean of its little portion times the whole thing. So that would be 30 times 5 or 5 times 30. All right, so here's the wrap-up. Here's kind of like your formula for everything. Okay, C is for this whole length right here. Should have had that on there. Okay, so to find the altitude, okay, it's going to be the geometric mean of the two little parts, okay, D times E, things it's chopping up. To find the legs, if I want to find this leg, it's going to be the geometric mean of its little part, its adjacent leg, times the whole original hypotenuse. So that would be D times C. Do the same thing on the other side. To find the other leg, you're going to get the geometric mean of its little adjacent part times the whole original hypotenuse. So that would be E times C. This would be the entire lesson on one slide. So if you write this down, that'll help you set up your problems until you start figuring it out. Okay, so here's your final example. I'm going to let you try the final example and see if you can get the right answers. I'm not going to work it out for you, and we will go over that in class tomorrow.